All right, this is lesson 14, and we are going to be working on percent error problems. All right, so let's look at example 1. How far off are we? This table is talking about a 15-inch TV, and 3 different students measured it, and they measured it twice, and they got different measurements each time. So the question is, what is their error? How much is their error? So a couple things before we start with this. We have 2 things that we need to know. One, we're going to say that A is the approximate measurement. And what I mean by that is that's like what you measured. X is going to represent the exact measurement, or what it should be. So what the first part of this is asking for is the absolute error. So we have a formula for that. The absolute error is going to be the absolute value of A minus X. So basically, how far away from the actual measurement are you? So let's look at Taylor's measurement 1. Taylor's measurement 1 is 15 2/8. That's how much she measured it to be. Now remember, this is a 15-inch TV. So the exact measurement is 15 inches. So the A is going to be how much she measured. The X is going to be 15. So we're going to bring our calculator into this. And we're going to do 15 2/8 minus 15, which gives us the absolute value of 1/4. Now the absolute value of 1/4 is 1/4, or 0.25. So that tells us that Taylor's measurement was 0.25 inches from the actual. That's how far off she was. All right, how about Connor's measurement 1? So we're going to do A minus X. So A is his approximate measure. 1 is 15 4/8. The exact measurement is still 15. So 15 4/8 minus 15 is 1/2. The absolute value of 1/2 is 0.5. That means Connor was 0.5 inches from the actual. Okay, and the last one, Jordan's measurement 2. So we're going to take his measurement 2, 14 6/8 minus 15. So 14 6/8 minus 15 is negative 1/4. Take the absolute value of that, and you get 0.25, or 1/4. So Jordan was 0.25 inches from the actual. Now we ended up with a negative there. That's just because he was under the actual measurement, whereas these 2 were over the actual measurements. All right, so now let's go to example 2. It says find the percent error. So those were how much error we had. Now let's find the percentage of error. So we have a new formula that we're going to use. Percent error is going to be equal to A minus X, the absolute value of A minus X, over the absolute value of X. And then we're going to multiply it by 100 just to make it into a percentage. So for Taylor's measurement 1, percent error is going to be equal to, well, if you go back and look at that chart, Taylor's measurement 1 was 15 2/8. So 15 2/8 minus 15, the exact measurement, over the absolute value of 15, and then we're going to multiply it by 100. So the order of operations is we're going to subtract the top first. So 15 2/8 minus 15 gives us 1/4. The absolute value of 15 is 15. So keeping 1/4 in your calculator, just divide that by 15. which is 1/60. I'm just going to change that to a decimal before multiplying it by 100. So 1.6 repeating is your percentage of error. So what does that mean? That means that Taylor's measurement was within 1.6% of the actual measurement. Now, if you look at the percentage, 1.6%, that's pretty small. So that means that the actual measurement was pretty close to the original value. All right, how about part B? Let's do Connor's measurement 1, which percent error. So the absolute value of Connor's measurement 1 was 15 4/8 minus 15 over the absolute value of 15, and then we're going to multiply it by 100. So let's do the top first. So 15 4/8 minus 15 is 1/2 over 15. So the absolute value of 1/2 is just 1/2. I'm going to get rid of that. Divide that by 15 is 1/30, and then I'm going to multiply it by 100. So if I want to change that to a decimal, I get 3.3 repeating percent. So Connor's measurement was within 3.3 repeating percent of the actual measurement. All right, and part C, we're going to do percent error for Jordan's measurement 2. So Jordan's measurement 2 was 14 6/8 minus 15 over the absolute value of 15 times 100. So let's do this. 14 6/8 minus 15 was negative 1/4, but the absolute value of that makes it positive. Divided by 15. So 0.25 divided by 15 times 100 is 1.6 repeating percent. So that means that Jordan's measurement was within 1.6 repeating percent of the actual measurement. So what is the purpose of finding this percent error? Okay, it's basically going to tell us how big the error is. All right, I'm going to have you try to practice this. And remember, go back to your notes and look to make sure you have the correct formula. When you're done with each question, just hit play so that you know you have the correct answer. All right, so go ahead and hit pause. And when you're done, make sure you have the correct answers. All right, number 1, we're going to find out the percent error. But first, I need to know what is my approximate and what is my exact. So a real estate agent expected 18 people to show up for an open house, 25 attended. So how many actually attended? That would be the 25. They thought that 18 was going to attend. So that's our approximate. So percent error is going to be the absolute value of A minus X over the absolute value of X times 100. So we have 18 minus 25 on the top over the absolute value of 25 times 100. So take your calculator. 18 minus 25 is negative 7, but the absolute value of negative 7 is 7. We're going to do 7 divided by 25 times 100 gives us 28% error. Now that's a pretty big error. 28% error is pretty large. All right, number 2. We need to know what is my approximate, what is my exact. So Mrs. Moore's students directed to weigh a 300-gram mass. They weighed it at 328. So the 328 is what they weighed. 300 was the exact measurement. So let's find the percent error. So A minus X over X times 100. So 328 minus 300 over the absolute value of 300 times 100. So bring your calculator in. 328 minus 300 is 28. Divided by 300. And then multiply that by 100. So we get a 9.3 repeating percent error. All right, last one. Darwin's coach recorded that he had bowled 250 points out of 300 in a bowling tournament. However, the official scoreboard showed that Darwin actually bowled 225. All right, so let's find the error. So we need to know our approximate and our exact. So the exact was 225, but they recorded 250. So percent error is going to be absolute value of A minus X over X. So 250 minus 225 over 225. So that would be 25 over 225 times 100. So 25 divided by 225, multiply that by 100, and you get an 11.1. Now my pencil's not going to work. 0.1 repeating percent error. All right, and that's it for this lesson. Go ahead and try the homework set or the problem set for homework tonight.